Hello and welcome to Day One Ops. Today we're going to talk about Terraform, what it is, some of the common use cases. Then next we're going to demystify Terraform versus Ansible and some other well-known tools. Next we're going to get into installation options. Then we're going to cover useful commands. And then lastly we're going to do a demo of Terraform. So moving on, what is Terraform? Terraform is a tool that you use to automate, provision, and manage your infrastructure. It's open source, meaning you don't have to pay for it, and it's cloud agnostic. So for those of you who may not be familiar with cloud agnostic is when, let's say you look at AWS, Google, Azure. So that means this tool can work across any one of those well-known cloud providers. Moving on to components. So the first thing you usually start with Terraform is the configuration files. These are written into a special language called HashiCorp language. Terraform also includes modules. Now, if you think of this is sort of like, this allows you to reuse certain parts of your code. So let's say you're working on multiple projects. So instead of recreating that, you could just reuse that module. And then there's a whole community out there full of other modules that other folks have created that you can also leverage. Next, you have providers and plugins. This goes back to what I mentioned earlier around the different cloud providers. Each cloud provider is considered a provider as well in Terraform. So you have one, for instance, for AWS, for Google's GCP, you have one for Azure. And on top of that, you have various plugins for the different services. Inside your Terraform config, you have what's known as variables. These are similar to some of your system variables. So this is considered a best practice when you're writing Terraform, is to use variables. And again, this puts the emphasis on reusability with your infrastructure as code. State file. Now, we won't go into this in depth as well, but a state file essentially describes the current state of your infrastructure. Now, this can be stored in a number of places. You can store it locally. You can also store it remotely in something like S3 or a HashiCorp or any other object storage that allows you to store and retrieve this file. An important thing I want to mention about this file is you normally want to make sure it's secure because it can include some of your sensitive information if you're not careful. Then you have Terraform Core. This is the core of the application. This is how everything works essentially. And then lastly, you have your outputs. So with any computer system, you have your inputs and you have your outputs. So the same concept applies here. Moving on to the common use cases. Infrastructure's provisioning. So if you want to leverage one of the infrastructure as a service tools out there, such as AWS, Google's GCP, Microsoft's Azure, you can do that, and you can use Terraform to provision that infrastructure. So if you don't want to use one of these three, you can also use DigitalOcean. DigitalOcean tends to be less expensive than some of the other ones. You can also, surprisingly, Terraform is not only for infrastructure provision, it's also for platform as a service and software as a service. So you can do some things like manage Kubernetes if you want to manage your Kubernetes deployments. If you want to deploy your application, you can do that as well. I haven't heard of a lot of folks out there doing that, but it is feasible. Another good use case for Terraform is for software demos. So usually when you're doing demos, you only have, you want to make a good first impression. And one of the ways you can do that is ensuring that whatever you do on your own in your own environment is repeatable when you do the demonstration. And Terraform is one way you can do that. It ensures you're able to deploy your infrastructure in a consistent manner. There's a significant emphasis on infrastructure as code. And Terraform allows you to achieve that by describing the state that you want your infrastructure to be in. Once you accomplish that, you deploy your infrastructure. So moving on to Terraform versus Ansible and some of the others. So starting with Ansible. So Terraform or Ansible is more, I would say, commonly used for application configuration management and deployment, right? It's a similar concept, meaning you're still writing code and you're describing the state that you want either your application to be in that language. But believe it or not, you can also use Ansible to provision your infrastructure in a similar way as Terraform. However, at the time of this writing, there's no state file management, at least that I'm aware of. So you probably would do that. Like say you were just trying to test something out and for the sake of simplicity and you just wanted to use Ansible to do everything from end to end, yeah, that might make sense. But if you're running a production environment and you want to make sure that your infrastructure is all in a consistent state and that state file could be shared across people that you work with, yeah, you probably want to use Terraform. So CloudFormation. CloudFormation is AWS's, I would say, proprietary tool, which you can use for deploying pretty much all the AWS services. Now, as you can imagine, anything with AWS in front of it is most likely AWS specific. I don't know if this may change one day, but at least at this current time, it's limited to AWS. So you can only use CloudFormation with AWS, which is not good. If you remember earlier when I mentioned achieving cloud agnosticity, Palumi, if I'm pronouncing this right. Now, I haven't worked with this one, but from what I researched, it does appear to be a similar concept as Terraform, if not identical. This one is they also offer, I don't know if they offer a paid solution or not. I have to check again, but it's out there. So Kubernetes. So sometimes this question comes up, so I just wanted to throw this one in there as an extra. So Kubernetes I would say Kubernetes is more on the platform as a service side. So you have your infrastructure, which you can use to deploy with Terraform or not. So once you have your infrastructure up, you would then deploy Kubernetes on top of that infrastructure. So whether that's bare metal or that's a virtualized setup, you would do that there. Then once you have that up, you can use Kubernetes to deploy your applications. So with that being said, it's really not comparable to Terraform in a sense. The only sense I could see it being comparable is when you're looking at ways to deploy your Kubernetes application. So for instance, you could use Terraform to deploy your Kubernetes application, and then also on the other side, you could use Kubernetes native support, kubectl, something like that, to deploy and manage your Kubernetes application. So that sums up some of the differences between all those different specific applications that are available. So let's move on to installation options. So with Terraform, you have a number of different installation options. Back when I first started out, I would use the binary and you can download that from and I'll put some links down below where you could download that from. But if you're on a Mac, you can use Homebrew if you have it installed. In the past, it wasn't always the latest, but here recently I just checked. It does seem to be in line with the binary, and so you also with Windows. I don't have any experience with this, but based on what I researched, you can use Chocolatey, which is Windows sort of homebrew approach, I would say. And then if you're on a Linux platform, you could use your standard Yum, DNF, or apt-get if you're on a Debian based. So lastly here, you can use the source. You can download it from source. Now this Terraform is based on Go, so you're able to package that in a single binary. You can download that binary directly to your laptop or PC or server, and then you just put it in a path, and then you can leverage it from there. So moving on to typical deployment process. So a typical deployment process in Terraform. So first you're going to start with your Terraform configuration. So with most cloud providers, you have what's called security groups. So you'll need to configure that. You can also do that with Terraform, or you can do it outside of Terraform. However, I'd recommend if you want to achieve true infrastructure as code to do all that inside of Terraform. So that way you have that consistency and you had that repeatability. So then you have the VPC, which in most cases was applicable to AWS and maybe some of the other cloud providers. I don't know if they call it VPC though, but then you have your VM. So first you configure all these things, and then that's the way, once you do this, you have an entire setup that you'll be able to access. Yeah, and I threw network under VPC because these two are, even though they're related, they're kind of separate. So for example, first you'll configure your VPC, and then next you would do any additional networking configuration, whether that's creating public IPs or elastic IPs and stuff like that, or configuring your routes. But if you already have that stuff in place, it kind of makes you kind of don't really need to configure the VPC again. That's normally a one-time deal depending on your architecture. All right, some useful commands with Terraform. So Terraform init, as with most other applications that use this, you're going to that's going to initialize your environment. That's going to create you all your standard sort of layouts, your .terraform, and we'll get into this later. Terraform get, that's going to pull in any of your modules that your project depends on, and those are specified in your configuration files. Terraform plan, in the past, I would say there was no forgiveness. So when you ran Terraform apply, that was it. It's gone. It's unless you stop the command midway, whatever you have in your config file is going to be applied. And that could be disastrous in some cases. For instance, you could blow away your entire infrastructure if you don't have things configured properly. So good practices, and now it's sort of baked into the apply command, is to run a plan. So that way you can see exactly what's going to change and if you need to fix something or not. So Terraform destroy, as you can imagine, that's going to destroy everything that's in your state file. Terraform refresh. Now, if you're dealing with remote states and stuff like that, that's when this comes in handy. You want to make sure you have the latest. So let's move into the demo. Okay, starting with the demo. Just want to go over real quick here. We have 3 files. We have main.tf, which I'm using to just output hello Terraform. So that's all that's pretty much going to be done here. We also have a providers file, and the reason I put this here is because I wanted to provide you with an example of what it looks like when you do the initialization and pulls in the providers that are required. And then the variables file is empty. So yeah, moving on here. So if you look at the folder layout, again, as I mentioned earlier, you don't see any .terraform, you don't see any .state. So we're going to create all that by running terraform init. So what's happening here is Terraform, it's going out and it's pulling down any of the plugins and providers that it needs to run this Terraform manifest. So now that's pulled in, let's take a look at that folder structure. We have our .terraform file. So next we need to run Terraform get to pull in any modules. Now, in this particular Terraform manifest, I'm not going to be pulling in anything because there's no modules to pull in, but I just wanted to run it just to show you. So next, we're going to run Terraform plan, and this is going to show the plan if we were to run this. Now, we really don't have to run this, but as I mentioned earlier, as a best practice, you normally want to run this just to be on the safe side. So now we see that the only change that's going to be made here is it's going to output hello Terraform. So let's run Terraform apply now. Now, Terraform is asking us, do we accept these changes? If we do, go ahead and type yes. And again, this is just a safeguard to prevent you from inadvertently destroying your infrastructure or making any changes that you don't want to make. So that's it. Hello, Terraform. Now we should have a state file, and we do. And the state file has in there hello Terraform. So that's it. Don't forget to like, comment, or subscribe. If you want to see more videos on Terraform, let me know down in the comment section, and thanks for watching.